They do allow looking at C# code, but what I don't like is that, again, this is why I feel that it's not going to be fun in C# here, because in GDScript they somehow make it very simple, and if you want the C# version, you are left with a lot of code to write. Here, because in GD personally I think C# support is rather troublesome.
Much later, because for now we don't really need it. Finally, at the top you can see a few more options, although those aren't too important for now, except for one. By default, Godot has a bluish tint, which I find really distracting. To change it, go to Editor and then Editor Settings. This opens a new dialog where you can update the theme. I will be using the gray theme, which is much more neutral. This new dialog is really distracting. To change it, go to Editor and then Editor Settings. This opens a new dialog.
So what's the difference? This is fine.
Dialog where you can update the theme. I will be using the gray theme, which is much more neutral. This only changes the color though. If you like the default or want other changes, just select what you like. That makes the editor much more pleasing to look at. Now that we have covered the basics, I want to actually create a couple of scenes and nodes. Specifically, I want to create 2 scenes and a bunch of nodes. Most importantly, I want to create a level scene. For now, this one is only going to contain some images, simply because that's the easiest thing to add. Besides that, I also want to create a player scene. This one also is just going to be a single picture for now. Finally, the last thing I want to do is to put the player scene inside of the level scene. That way, we can add a lot of stuff later on to the player, but still see the player itself inside of the level. Makes the organization much better. But for all of this, let's actually create some basic things in Godot. Here we are back in the editor, and since I want to create a 2D game, I want to work in a 2D workspace. We can select the different workspaces at the top. I want to work inside of 2D. And now we can see a 2D workspace. Let me zoom out a tiny bit. All of the gray area that you can see is the workspace. Although what you want to be aware of is that there is a blue rectangle. It's kind of hard to see on video, but if you have Godot open, this one is quite easy to see. This blue area is what's going to be visible to the player. This will effectively become the game window in just a bit. Or well, it already is, but this part is going to be visible. All of the stuff you can see right now is a scene. This scene at the moment doesn't have a name, which means at the tab on top, you can see empty. To give this scene a name, you have to save it. Something we are going to do in just a second, but right now we can't, because in order to save a scene, we need to have some nodes inside. The nodes we can get from the panel on the left. We can choose to create a 2D scene, a 3D scene, a user interface, or other node. If I click on other node, you can see all of the available nodes inside of Godot, and there are quite a few. For example, inside of node 2D, I can expand everything and see all of the available nodes. Now, I will cover most of them throughout this tutorial, But for now, all of this is going to get way too advanced. So I'm going to click on cancel. Instead, I simply want to create a 2D scene. This is going to create one node, a node 2D. This would be one of the simplest nodes you can create in Godot. Effectively, it is literally just a point in a 2D space. You can actually see it already. If you look at the canvas, there's this red dot, and if I hover over it, you can see node 2D. But this is literally what it is. It's just, well, a red dot. I can illustrate this a bit more because if you look on the right, we have transform. There we can set the position, the rotation, the scale, and the skew of this point. Rotation is going to be really easy to see. If I rotate the point, we get a rotated point. Although the player wouldn't see any of this. This point is only visible in the editor. And you might be asking, how is this helping for a game? And the answer is not very much, at least in terms of visibility. In Node2D, largely is used for organization. So you would add other nodes as children to this Node2D to organize your game. As a matter of fact, I want to rename this Node2D right away. I think level is going to be a much better name. Now that we have that, we have one scene with one node inside of it. And this scene I now want to save. This I can do either with Control or Command S, or by going to Scene and Save Scene. At the moment, we only have the graphics folder we imported earlier. Besides that, I want to create another folder that I'm going to call Scenes, all in lowercase letters. Inside of this Scenes folder, I want to create another folder. I call this one Levels, simply because later on we are going to have multiple of them. Inside of this Levels folder, I am going to save this scene. And you can already tell that we have level.tscn. Godot always chooses the name of the first node of the scene, which means in my case, the first node that we added to the scene is called level, and this is going to be the name that we get by default. And this is the one you probably want to use as well. So I want to save that. And now we have some minor changes. The most important change is that we now have a tab called level. This is the scene. Inside of this scene, we have one node, a node2D called level. This node2D doesn't do very much right now. It is literally just this point. We're going to do something more useful in just a bit. Besides that, we also have a new folder in our file system. We have scenes, there we have levels, and then we have level.tscn. Although let me minimize all of this because we don't need it right now. Now that we have a basic setup, I want to add a picture to this scene. For that, I will need another node. To add another node, I have to go either to this plus symbol or press Ctrl or Command and A. In either case, you are going to find this dialog again. Inside of it, you can simply select any kind of node, like multiplayer spawner, but this is not what I want. So let me undo all of this with Ctrl or Command Z. Instead, I want to look for a specific node. And since there are so many, most of the time when you add new nodes, you're using the search function. I want to look for a sprite, or more specifically, a sprite 2D. This is a node that can display an image. So if I double click on it, we have now added another node. And before I continue, something you do want to pay attention to is we have our level node. This is the parent, and this parent has a child, which is the sprite 2D. This parent-child relationship is really important. I'll cover more of it in just a bit. For now, just keep in mind we have a parent and a child, and the parent influences the child. That being said, we still cannot see any kind of image inside of the scene. For that, we have to look on the right, because there we have the inspector. We still can transform the image. So like with Node2D, we have position, rotation, scale, and skew, but we don't care about any of them. Instead, what we care about are the additional options. We have texture, offset, animation, and region. Texture is what we have to add to get a picture. And if you click on the dropdown, you can add a whole bunch of stuff. Although I don't care about that because there's an easier way to add an image. All you have to do is look at the file system. For example, in there, I have icon.svg. This you have in every Godot project by default. And this image, I simply want to drag into the texture, and you can see there's this blue frame around the field. So if I drop it in there, we now have an image. This is the Godot logo. And we can see it because we have a sprite 2D. This image we can now influence. For example, I can simply drag it with my mouse and move it around. And let me zoom out a tiny bit so I can see the entire game window. I can simply move this image around and place it in a certain position. Besides that, if you look at the inspector, we have a few more things. There's offset, and then there, for example, we could use flip H. That's not visible, but you can use flip V for flip vertical. You can also give it an offset, but I don't really care about any of these options. Besides that, we have an animation, but that's a tiny bit more advanced, so I'm going to ignore it. And we have a region. If you enable that, the image disappears. However, what you can also do is edit region, then you get another dialog. And in here, you can select one region of the image. So let me just cut out a part of it, and then click on close. And now you can see some slightly weird behavior. Don't worry about this too much, because later on we're going to work with this in more detail and fix these weird artifacts. For now, I'm simply going to disable the region, which disappears. However, what you can also do is edit region, then you get another dialog. And then here you can select one region of the image. So let me just cut out a part of it and then click on close. And now you can see some slightly weird behavior. Don't worry about this too much because later on we're going to work with this in more detail and fix these weird artifacts. For now, I'm simply going to disable the region and then we are back to the basic image. Finally, you can use transform and we could update the position, we can change the rotation, we could scale all of this.
Okay, perfect. Export the spreadsheet. Export. What the hell happens? Okay. Frames. Okay. And this one. Okay. Here. Crouch to crouch. And this one. Oh. This is very badly aligned. View. Yes. What? Crouch to crawl. So it's this one. Crap. What? Today I learned. Cheat. Oh no. Oh no, no, no. All good. Let's continue the video.
Or we could skew it.
Actually, script. Jeez.
Like so. And you can also see inside of the inspector, whenever we change the default value, you can reset it by clicking on the return arrow thingy. There we go. With that, we have added one image. Before we continue, there are two important concepts that I want to cover. The first one is the coordinate system of the window that we are working in. Right now, the window has a position, the one you can see inside of the inspector. We have x of 629 and y of 303. This means that we are 629 pixels from the left and we are 303 pixels from the top. The point we're talking about is the center of the node, by the way. This position can be a bit confusing. Basically what is happening is that we are creating a coordinate system with the origin point in the top left. This point would be 0 for x and 0 for y. If you want to place any element further to the right, you have to increase x. However, if you want to move an element down, you also have to increase y. If you are used to coordinate systems from high school, where the origin point is in the bottom left, this might be a bit confusing. Because what you have learned is that if you want to go to the right, you have to increase x. And if you want to go up, you have to increase y. Inside of Godot and most game engines, y is going to be inverted. Meaning, if you want to go up, you have to decrease y. If you want to go down, you have to increase y. Most game engines, in fact, most computer graphics work like that, so you kind of have to get used to it. It will take you some time, but eventually this will become natural. And just to demonstrate, let's move around this image a bit. Right now, the X position is 629. If I change this to 500, we are moving a bit to the left. If I change the Y part to 200, so we are going from 300 to 200,
Oh my god.
and I click enter, we are moving up. We have decreased Y, and because of that, we have moved up. This was the first important concept. Now we have a coordinate system that we can work in. Besides that, we have to talk about the relationship between the level and the sprite 2D. Level right now is the parent, which effectively means if you're changing the level, you would also affect the sprite 2D image. For example, if I change the rotation of the level, we are also rotating the image. Let me zoom out a tiny bit. If I rotate this level, we are rotating all of its children. However, if I simply click on sprite 2D and rotate this one, we are only rotating the image itself. This would also work with other properties. For example, if I click on level again, I can change the position to 200 and 300. And now the level node is on this position, and relative to that, we have the sprite. Which means inside of the sprite, if I change the position back to 0 and 0, we are at the point of the level 2D node. The interaction between any of these nodes is super important to understand. We always have a parent and a child. And whatever happens to the parent is also going to be applied to the child. And whenever we are transforming the parent, we are also transforming the child. Which means whenever we are changing either the position, the rotation, the scale, or the skew of the parent, we also influence the child. This, by the way, would also work with multiple nodes. So if I have level selected, I can click on the plus again, and you can see on the left side, we have recent nodes that we work with. I want to add another sprite 2D. Now, we have a second sprite, and this one right now is invisible because there's no texture. To give it one, and for this one, I want to use a different image. So let's say inside of graphics, there we have a car, and we have main. This is the main part of the car. This I now want to drag into the texture, and there we can now see a car. This car we can also move around. Let me place it roughly here. Now, if I select the level again, I can rotate, and now I am rotating both the image of Godot and the car. What I can also do, and let me rename these sprite 2Ds so it's a bit clearer what they do. If I double click on the first sprite 2D, this one is going to be, let's call it logo. The second sprite 2D is going to be the car. What I can now do is select this car and drag it on top of the logo image. What this one is doing is it turns the car into the child of the logo. And this means whatever transform we apply to the logo will also be applied to the car. So if I now change the rotation of the logo, for example, we would also rotate the car. The same would apply to scale or to skew. We always get multiple transformations. And of course, level would still apply to all of the children, so logo and car would both be affected. Let me demonstrate by using rotation again. We are still rotating the car. I hope this relationship makes sense. You basically always want to be aware of the parent node and then whatever children there are. Their relationships and how they influence each other is something really important to understand in Godot. So this is something you absolutely want to practice. As a matter of fact, let's practice this right away. I want you guys to create another scene. This scene is going to have one parent node, which is going to be the player. This is going to be a node 2D. This node 2D is going to have a child, which is going to be a sprite. And the sprite should be the player image. You can find it inside of the file system. And finally, for good practice, I want you guys to add another sprite to the player, and this is going to be a laser. Pause the video now and try to figure this one out.
child notes, blah blah, budget sprites, thief, put my thief here, scale up, where is the texture filter nearest? And sprite. Okay. Player. Child node. Finalize. There's a push because it's not. This is my laser.
To create a new scene, I should have covered that, sorry about that, but to create a new scene, all you have to do is click on this little plus icon. Now we get another scene. And I want to create another 2D scene, and this I want to rename to player. Let's save all of that right away with Ctrl S, and I want to go one folder up, so I click on the upwards pointing arrow, and now I'm back. Now we have another scene. Selected, now fix there. To Ctrl A, or the plus icon, and add a laser image. The laser image, if I minimize the player folder, we are getting from projectiles. In there, we have a file called blue.png. This I want to drag on the texture, and there we go, we have the laser. What we can now do is arrange the laser in such a way that it looks a bit better, something like this. Later on, we're going to spawn these lasers dynamically, so we're going to delete this anyway, the position doesn't matter so much. I just wanted you guys to practice placing nodes inside of a scene. And alright, with that, we have two scenes. We have a player, and we have a level. And while we're here, I want to change the node to the level with the position back to 0 and 0. That just feels a bit cleaner. Also, I want to reset the rotation, and then I can move the sprite and the car so that there's somewhat one scene inside of another scene. Specifically, what I want to do is to place this player inside of the level. And for that, we have this symbol. It looks like a chain. If you hover over it, it says instantiate child scene. You can also get this with Ctrl, Shift, and A. If I click on that, we get all of the scenes available in the game. And I want to get my player.tscn. If I click on open, we simply get another node inside of our game. And this is very hard to see, but on top of the car, we now have the player. I can move him around actually. Essentially what happened, I had the car selected, and on this car, I added another scene. And the scene we have gotten from what we created earlier, the player. And since I had the car selected, this scene became a child of the car, which is not exactly what I want, so I'm going to click on the player and simply drag it on the level. That way, we have the logo with the car as a child, and then as a peer, we have the player. If we are changing the logo or the car, it's not going to affect the player, because the player is not a child of the logo or the car, but it is a child of the level. To really understand how important this system is, let me make a change to the player. So right now, we have a player with a sprite and another sprite. If, however, I add another kind of sprite, let me, with the player selected, click Ctrl A and add another sprite. I want to add the grenade. I can add it to a texture and move it, let's say, roughly here. And also it's quite large, so I want to change the scale to 0.2. What is really important to understand now is whatever change we are making to this scene will show up inside of the level. So now you can see we have the grenade. We cannot select it from this level scene, but inside of the player, we could make updates to it. With that system, you essentially can isolate the player. And all of the code for the player could be in here, and then the level is going to be separate from all of that. Later on, this kind of system will become incredibly important to us. organize your game. You will essentially have increasingly complex scenes, and you place them inside of other scenes. I think when you are getting started in Godot, this can be a tiny bit overwhelming. So I would very much recommend to just play around with the nodes and the scenes to make sure you understand what you are doing. As a matter of fact, let's do an exercise. I want you guys to create another scene. That scene is going to be for a bat. Once again, the parent node is going to be in node 2D.
What?
As a matter of fact, let's do an exercise. Just play around with the nodes and the scenes to make sure you understand what you are doing. As a matter of fact, let's do an exercise. I want you guys to create another scene. That scene is going to be for a bat. Once again, the parent node is going to be in node 2D. This node 2D is going to get one child, which is going to be a sprite of a bat. You can find the images for that inside of graphics and objects. On top of that, I want you guys to add a few more images for the pillows on top of the bat, and just arrange them in such a way that they look decently okay. Once you have all of that, create an instance of the bat inside of... Now that we have covered the basics of nodes and scenes, we have to come to the next major topic, which is coding, which in turn is what you're going to use for all of the interactivity inside of your game. Meaning if you ever want to rotate, move, or scale literally any object inside of the game, you would need to add some code. Let's talk about it, and there are two major issues we have to address. Number one is how to code in Godot, and number two is how to influence nodes and scenes. I'm going to cover actually. Godot, though, GDScript is the default language. And GDScript, and simply means that if you know any script and common ones, we have integers, floats, booleans, you do a normal Python variable. You are declaring this one with a var keyword and then a variable name, and then you can assign any kind of value. Assign to declare this to down example Godot and boot down here in this one, and then what is use flows. You have to add it to a create, then have a new position. A node rather will start with an basically mean of the also, which is a function, and this is going to often same thing. The alternative looks like this. You have a dollar is what I jumped into earlier, and right now it's quite messy, so I want to clean things up a bit. I want to get rid of the player, so I'm just selecting it and then click on delete. Godot is going to ask me if I want to delete the player node, and I do want to do that. I also want to get rid of the bat, so delete A, and I also want to get rid of the car. Now, besides clicking on delete on your keyboard, you can also right click, and somewhere in there we have delete, all the way at the bottom. This is going to leave us only with the logo as the only node inside of the scene. For now, I want to return all of the values to their default state. So rotation should be 0, and position should also be 0 and 0. With that, we have a very basic scene. If you followed along so far, you don't have to clean up the scene on your end. I am just going to do it to keep things a bit more organized on my end. Now, to add a script to any kind of node, you have to use the symbol in the top left. This one here. It's a little scroll with a plus symbol. Before I am going to click on it, you have to be aware, depending on what node you have selected, if you click the button, you will attach a script to this particular node. Because remember, whenever you create a script, it always has to be attached to a node. In my case, I want to attach a script to the logo sprite. So I have this one selected, I click on the symbol, and then we get a new dialog. And in there, we can select a couple of things. First of all, the language, although right now we only have GDScript. Then we have inherits, and this is sprite2d. This is an option you basically never want to change. Then we have class name, you can ignore that. Then we get a template. For this one, you want to keep the default, don't worry too much about it. Then we have built-in script. You can ignore this one as well. And finally, we have the path. This is where we are going to save the script. In my case, I want to look at, let's say I want to go up one folder and save the script somewhere in here. I'm going to delete this later anyway, but for now, I'm going to save it inside of scenes as logo.gd. If I now click on OK, we are going to the script view. If you want to go back to 2D, you click on the top on 2D. And this way, you can change between 2D and script quite easily. On top of that, what you can also see now is that we have an icon next to the logo. We have the logo node, and on the right of it, we have a script. This is telling you that there's a script attached to this node. Should be fairly obvious. Other than that, we can now see a few lines of code. Besides that, what you can also do, in the top right, there's an expand symbol. If you click on that, you're maximizing the code window at least a tiny bit. Since I'm working on a small screen, I'm going to work with that. If you have a larger window, this shouldn't be necessary. Now, let's go through what we are seeing. On the first line, we have extends sprite 2D.
Hold on. Confused now. How did I open this? No. Okay. This one goes away. Okay.
This is really important. And this extends sprite 2D. Let me minimize this a tiny bit. This extends sprites 2D has to match the node that we have attached the script to. So in my case, I have attached the script to a sprite 2D, which is the logo we have created in the last part. Basically what this one is doing is it creates a new object from a sprite 2D and adds extra functionality, whatever we are adding to it later on. But to ensure that the sprite 2D still works, we have to inherit from a sprite 2D. That way we don't create some kind of new data. Since this is done automatically, you don't have to worry too much about it. Other than that, we have two functions. We have a ready function and we have a process function. I covered both of those earlier. Ready is essentially called whenever the node is ready. Process is called on every frame of the game. To actually use them, let me add a few print statements. I want to print the string ready when the node is ready. And then inside of process, I want to print, let's call it process. And now that I have that, I can run the entire game again by clicking on the button on the top right. So if I run this now, you can see, let me close the window.
Debug. Debug. this collapse? So cool.
In the bottom, we have output. This is where you can see print statements. Of that case, we want right of the inspector. Over it with which position. And Godot forward an X and a Y value. Which means if I add a 100 and a 200 in there, we are moving this sprite by 100 pixels to the right and 200 pixels down. And that is all we need to update the position. Meaning if I now run the game, you can see we have a new position for the sprite. Originally, it was at this position, but we moved it down there because of the ready function. On top of that, we are still printing process because of the process function here. But other than that, we have a really good start. What you can also do inside of process, we can target position.x and then add a small amount, let's say 10. If I now run all of this again, the sprite is going to move to the right. There we go. Basically, what is going to happen is that we are increasing the position X by 10 pixels on every frame, which basically makes it move a tiny bit further to the right every time we're creating a new image of the game. This would be some super basic stuff. To extend this a tiny bit, we can create a couple of variables. For that, all the way at the top, outside of the functions, you can either use var or const along with the variable name. In my case, I want to create a
No. Oh. Come on. Seriously? Right, of course. So if I do this position and do this X plus 100. Yes, good. So it's the same.
variable. And I call this one the position. Since this is going to be a vector2, I want to force a certain kind of data type, which is vector2. And now with an equal sign, I can actually assign a value. Since I will need a vector2, I will have to type vector2. Now this vector2 has a couple of nice extra methods that we can work on. For example, if I add dot and 0, we are creating a vector with 0 and 0. Meaning this would be the same as a vector with 0 and 0. Besides that, I want to create a constant with the speed, because this is not something that should change. Although it should be an integer, so I'm going to tell it that the data type always has to be an integer. And now for the value, let's say 10. With that, we have created two variables inside of this class, and those two variables are available everywhere. We could use them inside of ready, or we could use them inside of process, or we could use them in any other function that we create ourselves. Which means for the position, let's say I want to update my pos variable that I just created and give it a vector 2 with 300 and 200. This by itself would not affect the game in a visible manner, because right now we have created a new variable that has a vector 2 value, and then we are assigning a new vector 2 value. We are not actually updating the position of the sprite. For that, we would need the position attribute, and then give it the position variable we have just created.
Holy crap.
The same thing we can do inside of process. Instead of updating position.x directly, I want to get my pos.x and then plus equal the speed, and then I can assign a whole new value to the position, which is just going to be pos. With that, I can run the code again, and we're going to get a similar result. That's looking pretty good. What you could
One is enough.
can also do is declare local variables inside of every function you have. For example, inside of the ready function, I can create a new variable. Let's call it test rotation. For value, I'm going to go with 45. The specific number here really doesn't matter. Once I have that, I can get the rotation. Once again, I get these names from hovering over the value inside of the inspector. So there I have rotation, and if I hover over it, we get rotation. One thing you do want to keep in mind is that rotations are in radians. So if I want to use 45 degrees, I would want to use rotation degrees, which means inside of the code, I want rotation degrees, which is going to be the test rotation. If I run this now, we should have a rotated sprite, and that is looking really good. Now the sprite is rotated by 45 degrees. Keep in mind now that this test rotation is a local variable inside of the ready function. We could not use it inside of process. If I try to, for example,
Where is my script? Okay, how do I see expose variables? I don't. Why?
example, print test rotation, we would get an error. And you can already see that Godot is telling me that Godot can be base, but can also be kind of GD script. I want you guys to create another variable called test scale. Make sure that the data type for this one is an integer, and the default value should be 1. When the game is ready, use the variable to change the scale to 2. On top of that, while the game is running, continuously increase the scale by a very small amount. Choose whatever you like. Pause the video now and try to implement this one. Back in the code, I want to create another variable. For the name, I want to have test scale. And on top of that, I want to force a data type, which is going to be an integer, and the default value should be 1. With that, we have created a new variable. Next up, inside of the ready function, I want to use this test scale to change the scaling of this node to a 2. For that, I want to get the test scale and set it to 2. And next up, let me minimize this window a bit so I can see the inspector. We want to look at the scale. And there you can see the node scale. The unscaled value is 1 and 1. And whenever you see two parentheses, it means it's a vector. The problem is, inside of the code, we're using an integer for the test scale. So we have to adjust a tiny bit. But let's play around first of all. I want to update the scale. And the scale should be the test scale. And now we are already getting an error. And once again, let me extend this window so we can see what's going on. We are trying to assign a value of type int to a variable that wants to have a vector 2. So this is not going to work. Scale always wants to have a vector 2. But that we can account for quite easily. All we have to do is get vector 2 and then pass in the test scale for x and y. And now the GODOT debugger is happy again. With that, I can run the entire thing. And now the GODOT logo is twice as large. Perfect. Which means with that, we can work inside of the process function to continuously increase the size. For that, I want to get the test scale again and increase it by a very small amount. Let's say 0.01. Other than that, I want to get the scale property and set it to a new vector 2 with the test scale for both x and y. Let's try all of that. And now it's not growing. Let's instead change it to a 1. And now if I run this again, this is definitely working. The issue with adding 0.1 is that test scale is always going to be an integer. And when we add 0.1, we would get 1.1. And since the value for test scale always has to be an integer, GODOT only takes the first value, which is going to be a 1. Anything after that is going to be ignored. If we had a float, this would work better, but in this case, the code is only going to work if we have full numbers, like 1, 2, and 3, and so on. But alright, with that, we have a couple of really important basics of GDScript. That being said, there's still quite a bit to go. The really important issue that we have right now, let me minimize all of this and return back to the 2D scene. Right now, we can only influence the logo itself. But what if we wanted to go from level and then influence the logo? This we can't do right now. But this video is getting quite long, so let's do all of this in the next video. Let's continue talking about coding in Godot. And for this part, I want to focus on two major things. Number one, targeting one node from another node, which means I want to use the level node to influence the sprite. On top of that, I want to work with the flow. So we're going to use some if statements and some for loops. Let's jump right in. If you got so far, this shouldn't be too difficult. Here we are back in the code, and you can see we have a level node and then a logo node with a script. All of the stuff we have done in the last part. What I now want to do is to give the level node a script as well, which I do by attaching a new script. All of the default options for this one are okay. I usually don't change any of those besides the path. What you see most of the time is that people change the script next to the scene that it is attached to, which means in my case, I want to add the level script in the same folder where we have the level scene, which is what I have right now. So I'm going to click on open and then on create. Now you can see to do is to give the level node a script as well, which I do by attaching a new script. script. All of the default options for this one are okay. I usually don't change any of those besides the path. What you see most of the time is that people change the script next to the scene that it is attached to, which means in my case, I want to add the level script in the same folder where we have the level scene, which is what I have right now. So I'm going to click on. Open. And then on create. Now you can see we have two script symbols because both of these nodes have a script attached to them. We also have the scripts available in here, which is quite nice to switch between the two. Now inside of the level, you can tell that we don't have the functions we had inside of logo, but that is only because of the preset I have selected. You can totally add func and ready, and then you get the same function. In there, I can print, let's say level node is ready. And once I have that, I can run the entire thing again, and let me close it right away. And look at the output again. There we get level node is ready, meaning this ready function works just fine. These underscore functions you have available all of the time, meaning you can always use ready or process and a host of other ones. Let me minimize the output, and then we can work a bit more inside of the level script. Now, I could be running any kind of code, the same thing we have done inside of the logo. But I want to do something else. What I want to do is from inside of this script, level.gd, I want to update the logo. And let's say I want to update the rotation. That we can do quite easily, but first of all, I want to go back to logo.gd. And in there, I want to comment out the test scale, because this is scaling everything too fast and we can't see what's happening anymore. To comment out code in GDScript, you would use Control or Command and K. If you add that, you are adding a comment. Alternatively, you can also simply add the hashtag symbol and then you're adding a comment. So I can get, for example, to positions, add the hashtag, and then you have commented it out. Both is fine. I tend to use Control or Command K because it's a bit faster, but choose whatever you like. With that, if I run the code again, you can see that we have the Godot symbol moving to the right, and we have a starting rotation of 45 degrees, which is what we're getting here. Let's comment out this one as well, so we are starting with a rotation of 0 degrees. That is looking like a good start. Now, inside of level.gd, I want to change the rotation of the logo. For that, we first of all have to get the logo, and this is what I talked about in the last video. Let me bring up the slide again. There, towards the end, I talked about that we can target nodes in two ways. We could either use getNode and then a node path, or a $sign along with the node path. Both of those would give us a node. And then on this node, we can change the properties. For example, we could get the node path and then dot position. I hope you can read that. And we could simply attach a new vector too. Back in Godot, I want to get a node. And now the autocomplete is already giving me a couple of options. We either have a dot, which doesn't do anything, or we have the logo. And with that, we have the logo. What we could do now, for example, is to change the rotation, and for that, we need degrees. Let's change it to 90 degrees. With that, if I run all of this again, there we have a 90-degree rotation for the Godot symbol. This is
work? Why? I need to have this? No. That's nice. Why is this not working? I'll just try to re-add this. I think that's it. Yeah. Close. 9. Yeah. Okay. What happened? I don't know.
Is one way to get a node. Alternatively, what you're probably going to use much more often is a $ and then the name or the path of the node you want to target. In this case, logo. If I run the entire scene again, we're getting the same result. As a matter of fact, you don't actually have to type it. What you can also do, if I get rid of it, you can simply select and click on the node you want to get and then drag it into the code editor. And if you then drop it, you get the name of the node, or rather the path of the node. Same thing. This we can also target multiple times. For example, we can once again use func_process, then get the logo with $logo, and then the rotation in degrees. We could, for example, plus equal 0.1. If I now run the scene again, we get a very slow rotation. Let's increase the number by a fair amount. Let's say I want to increase it by 1 degree on every frame of the game. That is much more visible, and certainly it is working. To make it even more visible, let me change it to a 10. If I run this again, much more visible. Cool. That is what I wanted. So with that, we can now target other nodes. Next up, I want to work on the flow. Let's say I want to add an if statement that if the rotation is greater than 180 degrees, I want to change the rotation back to 0. For that, we will need an if statement. I want to get if, and then I can target the looks same node shift again. Then shift horizontal axis. One in, now that we are moving, now that one in the entire scope of the class, I want to create var. This is actually what we have already done. If I jump back to Godot really quick, when we move the logo, we set, which means on every frame of the game, frames per one. Might have frame 30 frames at 10, 1 you can last mode, and we want to count for it. Create a solution. Why this works? This table is somewhat similar compared to what we have seen earlier. We still have our speed with pixels per frame, and then we have the frame rate. Originally, what we have seen was this column, where we are getting different movements depending on the frame rate, which was really bad, so we have to account for that. And for that, we have added another column for delta time. Now, depending on the frame rate, we are getting a different delta time. If our frame rate is 30 frames per second, we simply divide 1 second by 30, and delta time would be 0.033. If our frame rate is 60, we would divide 1 by 60, and we get 70 milliseconds, or something approximate to it. And if our frame rate is 120, we divide 1 by 120, and we get 0.08. These numbers we can then use as a multiplier for the frame rate, which is what happens in the final column. For example, for 120 frames, we are moving by 10 pixels per frame at 120 frames per second. Way to we are literally the low and counted. The game is going to run at the same speed, my speed, and then multiply it by delta. The issue now is if I run all of this, this is going to be really, really slow. We basically have no movement left. The reason for it, the speed right now is 10 pixels per frame, and delta time is incredibly 200. The if statement also still works regardless of the frame rate. Now, in my case, I can't easily control the frame rate, so this is a bit difficult to visualize. But trust me, this is a very easy thing to implement and really important for a consistent game experience. On top of that, if you look at the bottom, the debugger is now a bit less unhappy. We only have one issue left. Fixing that one is going to be your exercise. I want you guys to use delta time in level.gd, more specifically inside of the process function of level.gd. Pause the video now and try to implement this one. Back in Godot, I want to look at level.gd, and there we have process with delta. For this one, we have two things. We are updating the rotation, and then we are setting the position. We only need to use delta for one of them. When we're updating the rotation, this one, we want to multiply with delta. And now remember, the rotation is going to be incredibly slow because delta is such a low number. Let's try actually. Now we have a very, very, very minor rotation. To make this more noticeable, let's change this to, I don't know, 60. That is more visible. And once again, this rotation is now frame rate independent. We do not need to apply delta for this if statement where we're updating the position, because this one is not a change in movement. We are simply setting the position of the frame to x being 0. We are not continuously updating the movement. We are only doing this once. Because of that, we are not going to need delta time. In the future, we are also going to encounter quite a few functions that apply the movement with delta time automatically in build. So quite often, you don't have to think about delta time at all, but it is a really important concept. You are going to see it fairly often, and it is super important to understand. So I hope this part was useful. A really important part for any game is player input. So let's talk about that. To capture any kind of input in Godot, there are two steps. Number one, we have to create an input map. Basically, what this one is doing is it allows you to capture different kinds of inputs and store them under a certain keyword. For example, we could get the left key on the keyboard and the A key and store them both under the left keyword inside of the input map. That way we can access both of these keys inside of the game very easily. We could also account for the mouse, joysticks, controllers, basically anything. Once we have all of that, we have to access the input. For that, Godot has an input object, and this is allowing us to capture various kinds of inputs. All combined, this should be quite easy to implement. Once again, here is the project we have created so far. And I want to get started by creating an input map. For that, we have to go to the top. There is project, and there we have project settings. If you look at the top, there we have an input map. And right now, it's completely empty. For that, we have to create a new action first of all. This would be a category that can capture different kinds of input.
Project here. I'm working again on my logic simulation project, and I'm making use of the graph node in Godot, and I've produced a tutorial all about it on my website gdscript.com, and I'm very proud of this tutorial. It's the best I've ever done, I think. So let's just talk you through it. Like, we are using the graph node and the graph edit nodes. The graph edit, it gives you this region on the screen, which is like a control container that you can drop in the graph nodes into, and it can display a grid, and it's got various things like zooming in and out and snapping to the grid. And here's my code. Click there, and you can see there's a lot of I've created a lot of fun.
Very interesting.
Inputs. For example, the one we could start with is left. Now we have one action called left, and this action should have a couple of keys associated. For that, I want to go all the way to the right. There's a plus symbol, and there I can add an event. And here we have keyboard keys, mouse buttons, joypad buttons, and joypad axis. Basically any kind of input. Now, the list for all of them gets quite long because, well, there are a lot of keys on the keyboard. So most of the time, you don't go through the list. Instead you click on listening for input, and then you press the button on the keyboard that you want. So in my case, I want to have the left button, so I click left. And that way, we find the key automatically. Then I can click on OK, and now we have the left physical button. This is the left key on the keyboard. We can also add a second key to this action, which I do again by clicking on plus, and the other key I want to add is the A button. So I just click on A and click on OK.
Okay, input map, a new action, the left key, or no, shift plus A, what? No. Okay. Then this one is the left button. Okay, nice. The right one. Right. Oh no. Right. Can I drag it? Right. Right. Come on. Right. And the
With that, we have left and A, and they both represent left inside of the game. We are going to add quite a few more actions later on, but for now, I want to keep it simple. So let's close the input map and see how we can use it, which is bringing us to the second step. We have to access the input map, and this is going to happen with code. So let's say inside of the level, I want to open the code and make some updates to all of this. The code we are going to write has to be inside of the process function, because this one is going to run on every single frame of the game. If we try to run the code for the input in the ready function, it wouldn't work, because ready is only running for one frame when the game is starting. After that, it wouldn't do anything, so checking input in there would be pointless. Which means inside of process, I'm going to add a few more lines, and the most important line is going to be input. And you can see Godot is coloring this one already, which means this is a special keyword. To understand what it's doing, I think the best way to start this is to look at the documentation. And for that, Godot is amazing. Because if you hold Control or Command and you click on Input, then Godot is opening the inbuilt documentation. And in there, you can read anything that you could possibly need about the input object. There's quite a bit, so let me extend the entire thing. And there are all of the methods that you have on the input object. A really easy one, if I scroll down a bit, is action pressed. This one is simply checking if a certain action has been triggered or pressed on the keyboard. Let's use this one. For that, I'm going to stop using this in full screen mode and go back to the level. On input, I want to run a method. So I add dot and then isAction. There we can choose just pressed, just released, or simply pressed. I want to go with isAction pressed. And now we can look for the various actions. Godot has a couple of predefined ones, although all the way at the top, we have the one that we created, which is called left. And now, whenever we are pressing the button, or rather whenever the player is pressing the button, This is going to return a boolean that says either true or false. True if the button is pressed and false if it isn't pressed. Which means we can simply print all of this and we should see either true or false. Let me run the code. And now I get false because the key isn't pressed. But if I click on the left key or on A, we're getting true. Which means we can register for the key press. Cool, this one is working really well.
I actually think it's the other way around. Yep. This window like application. Yeah. Okay, next.
Just is document where it's and is forward just on. Okay, I write my
Primary action could be like everyone. This one. This one. No. Primary. Yeah, sure. Primary. Nice. Mouse buttons. Mouse button. Sure. And secondary. Let's add this one. Right. I want to delete this one for now. Or much Godot to
Hello, ladies and gentlemen. It's Mike here at Games from Scratch. Part of that is Writer is being positioned as that you're going to be to any job is back or the plugin. You might it's just sorry. It's very much actually developed and made.
where is it? Where is the marketplace here? Where is it? Where is it? Marketplace. Oh, come on. View. File. Plugins. Thank you. Start. What do you do? Okay, so let's do this. Holy crap. This is way too happy. Sexist. Okay, let's continue.
To the editor, I don't want to move this sprite that we have created earlier. Instead, I want to move the player. And for that, I want to clean things up a bit. I don't need the laser image anymore, so I'm going to get rid of this. And this sprite 2D for the grenade, we can also get rid of. That way, we are left only with the player image of this. And let I the image itself. To move all of them, we are moving at the dialog template. You either have default, and this one includes the ready function and a script to all of them together. For that, the script is going to go on the player to get a whole bunch more children, and we want to move all of them together. For that, we have to move only the parent node, and since we apply the same transform to all of the children, we are moving all of them if we move the parent, which means the player is going to get a script. Once again, we get the dialog to create a new script, and the one thing I should have mentioned earlier, when you click on template, you either have default, and this one includes the ready function and process, whereas if you have empty, it doesn't include anything except the extend statement for the inheritance. I'm going to go with empty because I like to start clean, but you can choose whatever you want. On top of that, for the path, I want to save the script, so player.gd, in the same folder where I have the scene for the player, which I already have. So I can click on open and create. There we go. Now the player has a script. To check for input, once again, we will need the process function. And first of all, in there, I want to get the input. And this I can do in a couple of different ways. Although there's one method that is the most succinct and the easiest to use. Let's have a look at input, because in there, if I scroll all the way up, we have a whole bunch of methods that we can use. And let me extend this window a bit so we can see things better. The method that is going to be most useful for us is called getVector. If I click on that, we get a bit more detail. This method is designed for top-down movement. Basically, what it wants is 4 different actions. One for negative x, or left, then positive x, so right. After that, negative y and positive y, which would be up and down. We could also add a dead zone, but we don't need to, so I'm going to ignore it. Once we have these 4 actions, Godot is going to return a vector, and this vector is going to give us the movement. For example, if the user only pressed the negative x action, we will get a vector that points at -1 and 0. So we are just going to the left, no up or down. If you just read these things on your own, I think especially at this stage, this is probably a bit confusing. And when you get started with coding, reading documentation can be a bit difficult. But if you have a bit of practice, all of this should become quite easy to understand. But, well, it does take some time to get used to it. Anyway though, I want to minimize this window and work inside of the player. To get the input, I first of all want to create a new variable. Let's call it var direction. And this direction I get with input and then dot get underscore vector. That is the method we just looked at. This one, and now we have to go through the different actions for the 4 directions. We have to start with negative x, which is a fancy way of saying left. Then we need positive x, which is just right. Then we need negative y, which is up. And finally, we need positive y, which is down. Once we have all of those, Godot stops complaining, and we are getting a vector. To make sure this is working, let's print what we are actually getting from direction. And before I run all of this inside of the level, I want to comment out the print statement, so we only see the output for the direction, and it's not going to get too confusing. Let's run all of this, and now by default we get 0 and 0, because I'm not pressing anything. However, if I press the left key, or I press A, then we get -1, because this is now telling the game that we want to move in the left direction. I can also press up, or down, or right, or 2 keys combined. Then we get a slightly less pretty vector, but it certainly works. The same would also work with WASD. We get pretty much the same output. This is looking really good. Which means with all of that, we can get the input and then we just have to use it to move the player. To actually move the player then, we have to target the position. And once again, I think for this, it's easiest to have the inspector open because what we ultimately want to change is the position of the node 2D. And this we can target with the position, which by itself is going to be a vector. All we have to do is position plus equal the direction and then times some kind of speed. Let's say 200. On top of that, what I covered in the last part, do not forget delta whenever you move anything continuously. Now, once we have all of that, I can run the code again, and now we can move the player around. It's quite slow, but it definitely works, so I am quite happy with that. It might be a good idea to increase the speed to, let's say, 500, and now we can move much faster. This is feeling better. But this would be the basics of movement. Later on, we are going to change that to account for physics, but for now, this is working just fine. That being said, I do want to add one more thing though, because right now, we are just able to move. The player wouldn't have any way to input a shooting mechanic. For that, I want to add a bit more code. Let's call it the laser shooting input. I want to check if the player is pressing the primary input. I need an if statement, and this is going to look very similar compared to what we have done inside of this print statement. I want to check the input, and then is action pressed. Which means inside of the player, I want to get the input, and then is action. For this one, you could use either is action just pressed or is action pressed. Later on, we are going to have a timer to delay the laser shooting anyway, so the difference here is negligible. But the action I'm looking for is primary action. If that is the case, for now, I simply want to print, let's say, shoot laser. And now I can run the game again. Now, if I click with my mouse button, I get shoot laser, or if I press space, we're also getting shoot laser. So this is working just fine. And that is covering all of the basics of keyboard input. All we have to do now is do an exercise, and then we are done. I want you guys to create another action in the input map and call it secondary action. The associated keys are control, left control to be more specific, but it doesn't really matter, and also the right mouse button. If that action is triggered, print shoot grenade, and all of the code should be is covering press space. If that is the case, for now, I simply want to print the action on. This is going to, I want to just able to move. The player wouldn't have any way to input a shooting mechanic. For that, I want to add a bit more code. Let's call it the laser shooting input. I want to check if the player is pressing the primary input. I need an if statement, and this is going to look very similar compared to what we have done inside of of this print statement, I want to check the input and then is action pressed. Which means inside of the player, I want to get the input and then is action. For this one, you could use either is action just pressed or is action pressed. Later on, we are going to have a timer to delay the laser shooting anyway, so the difference here is negligible. But the action I'm looking for is primary action. If that is the case, for now, I simply want to print, let's say, shoot laser. And now I can run the game again. Now, if I click with my mouse button, I get shoot laser, or if I press space, we're also getting shoot laser. So this is working just fine. And that is covering all of the basics of keyboard input. All we have to do now is do an exercise, and then we are done. I want you guys to create another action in the input map and call it secondary action. The associated keys are control, left control to be more specific, but it doesn't really matter, and also the right mouse button. If that action is triggered, print shoot grenade, and all of the code should be inside of the player right below the laser. Pause the video now and try to figure this one out. First of all, I have to update the input map. This I'm doing inside of project, input map. I want to add another action. I call this one secondary action. Now that I have the action, I have to add a couple of keys. I want to add control, so I just click control on the keyboard. Besides that, I'm going to click on the plus again, and I can click next or we get laser, and we can also still move around. So all of this is coming together quite nicely. Perfect. Before we continue, I want to cover some more minor topics. Specifically, I want to talk more on nodes. Even more specifically, I want to talk about how to interact with nodes via code. We have already seen some of that. To bring up an error node nodes and what to do, I usually want to emphasize because I can open the logo node, notice logo, I first let go, and I want to add control D. D times of a can to be quite useful. Because let's say you wanted to target this sprite to D4, and let me rename it to target, so it's a bit easier to understand what's going on. Let me just drag That is, if this sprite2d becomes more complex and you have more nested nodes, this is the kind of thing you will see quite often. But it's still not too bad, and for example, what you could do right now is simply print the node, and let's not do this in the process node, and instead put all of that inside of the ready function. That way we don't clutter the output. If I now run this, we get inside of the output target and then a sprite2d somewhere with a unique ID. Meaning all of this is working just fine. Now, if you feel like this is becoming too hard to read, which it might actually become, you can give this target node a unique name. To give it one, you have to right click on it and then access as a unique name. If I click on that, we have a percentage sign on the right side of it. What this one means, if I now delete this path and drag the target node again in there, we are now getting a percentage sign and then the target. Although the result is going to be the same. We are still getting the target, which is dried off as a unique name. If I click on that, we have a percentage sign on the right side of it. What this one means, if I now delete this path and drag the target node again in there, we are now getting a percentage sign and then the target. Although the result is going to be the same. We are still getting the target, which is a sprite2d, with some unique ID. Basically what this one is doing is it gives this target a unique name that you can access anywhere inside of the scene. For example, if I wanted to work inside of the logo, where we are simply moving a sprite right now, I could also target the same node. I can simply, let's say, I want to have the percentage sign, then the target. That would give us the entire node. And on that,
How do I get specifics? C sharp. Get nose.
Functions there.
That I could, for example, get the position. If I spell this correctly, this would also help a lot. And now, if I run all of this again, we are getting a position, which is 0 and 0. With this kind of setup, it's much easier to work in larger scenes. Although don't overuse it, if you add this kind of thing to every single node, the system kind of becomes pointless. So use this sparingly, but in certain situations, I want to get rid the target node doesn't exist anymore. The last thing I want to cover is what if you have a child node, like this logo 2D with a script, and you want to access something inside of the parent, in this case, the level. For example, right now, inside of our level, from really important
The parents.
Let's- of these nodes, a character body 2D. This includes
Okay.
are nodes for the layout. We'll cover those to some extent later. But this is quite a large topic, so this is going to be a separate video. We also have 3D nodes, and then we have a lot of general nodes. For example, there's a timer. We cover that quite soon, actually. For now,
That's
I
cool.
want to work inside of Node 2D, because we're making a 2D game. In there, we have lots more nodes, but at
Oh
the top,
my
we have
God.
collision object 2D. If I expand that, we get physics body 2D, and we get an area 2D node. We can also expand physics body 2D, and there we have a static body 2D, a character body 2D, and a rigid body 2D. We can expand things a bit more, but we don't need to. These 4 nodes are incredibly important, so I want to talk about them in quite some detail. There are 2 major parts for every one of these nodes that you have to be aware of. Number 1 is what they do, and number 2 is how you would move them. Because now that we are working with physics, the movement gets a bit different. Most of the work is done by Godot, so we're not going to do anything complicated. The easiest node that we can talk about is area 2D. This is just an area that can check if another body has entered. This area you can also move by changing the position, which is quite easily done. A good example for this one would be if the player is entering a house. The house would be an area 2D, and this area 2D can check if a body has entered. Besides that, when we are creating the lasers later on, those will also have areas attached to them. And those areas are going to check if the laser is colliding with an enemy or a wall or an obstacle or something like that. Next up, we have a static body 2D. The name gives you a pretty good idea of what this one is doing. It's a static body that is colliding with other bodies. As a consequence, there's no movement for this one. I guess in theory you could be moving it, but you're not supposed to. Examples for this one would be literally any static object in the game. Any kind of wall, any kind of obstacles, and what we've already created, the bat, is going to be a static body 2D. Which means later on, other bodies can collide with them, but they cannot move themselves. They are the easiest kind of collidable body we have. Next up, we have a rigid body 2D. This is a body that moves purely via physical forces. Think of it like a cannonball. If you want to move them, all you have to do is set a velocity when you create them, and then the body is going to move on its own. We are not going to use this very much, but when we're going to create the grenade later on,
So I think this is like a trigger or something. This is like an obstacle collision in Unity, and this I don't know.
we are going to use a rigid body 2D. Because for the grenade, all we have to do is set a velocity, and then it's going to move on its own. Finally, the most important body is character body 2D. This is a moving body controlled by code, and you are moving this via inbuilt methods. There are a couple depending on what kind of collision you want. I'll cover this in just a bit. But essentially, any entity controlled by code is going to be a character body 2D. This includes the player and all of the enemies. And when I say an entity controlled by code, I mean some complex movement. For example, the player has a complex movement of a direction that we get via input, and then a certain kind of speed. The enemies would also have some slightly more complex movement. Although for now, I covered a whole bunch of theory, so let's return to the editor and let's do something more practical. Back in Godot, I want to create a couple of physics bodies. And let's start with the easiest one. I want to update the bat. Because right now, we have a node 2D as the parent, and then we have 3 sprites attached. To update this, I want to change the parent node. So this node 2D, I want to turn into a static body 2D. For that, I have to right click on it, and there we have change type. Right now, we have a node 2D. This is not what I want. Instead, I want to go to node 2D, collision object, and physics body 2D, and there we have a static body 2D. Alternatively, you could also simply type in static body 2D.
How do I keep the changes? No. scene, you inherited scene. What? No. I don't understand. This works. It's risky, but it works. Sprite. Okay, this will be my static object. Uh, Killer here, and place static body 2D. Now, what is this? Has no shape. Has child to define its shape. Okay. Shape. Fine. This won't work, but okay. Now I go inside here. Add some polygonal collision. Now this is going to be a problem. Oh my god.
And you will get the same result. So now we get a static body 2D. You can see that the icon has consider adding a collision shape 2D or a collision polygon 2D as a child to define its shape, because it doesn't know what's. And what we need is a collision shape 2D or a collision polygon 2D. Allows you to collision shape 2D. Now we're getting another warning. Add this shape, it's going to the shape, select it again, and scale it up so that it fits the entire physical shape of the to select tip of the, if you graph as the axle again. This blue area is purely for debugging purposes, so you know what the actual collision collision. The reason for that though, if I run the game again, I can move the player in shape, but the player is vision, which means no to height. He has no shape. Body, a bit more complicated, because if you look, this is now giving me a circle, and this circle I want to expand a bit to something like this. And on top of that, I want to get the player image and move it so it's roughly in the middle. I would recommend to always keep the collision shape around the center. So right now, this character body has a center around the position 0 and 0. And this 0 and 0 I don't want to change. So I keep the collision shape around this position and then move the player to align with it. With that, we have a collision shape. This sort of setup, where you have a character body 2D, an image, and then a collision shape, is incredibly common in Godot. Basically, any kind of game for any scene is starting with something like that. That way you get collisions, you get movement, and you can see what's going on via the image. And if you don't have movement, like for the bat, you would have a static body 2D, then an image or multiple images, and then another collision shape. So this kind of setup is something you really have to understand. That being said, right now, if I run the code again, I still don't get any kind of collision. So something still isn't working. The reason why that is, if I look at the player and open the code, we get one problem. And this is we are extending a node 2D. This is because early on, we created a node 2D and attached all of the code. But we changed the node. Now we don't have a node 2D anymore. Instead, we have a character body 2D. So we don't want to extend a node 2D, we want to extend a character body 2D. Now that we have that, I can run the code again, and we still
What is wrong with you, man? What is wrong with you? What is wrong with you?
People don't get the collision. That is because we are right now updating the position, which is not how you are supposed to use a character body 2D. As a consequence, let me get rid of this position. Also, I want to extend the code window so we can see a bit better what's going on. To update a character body 2D, you want to use a specific method that is called move and slide. You don't have to add any kind of argument, this one works by itself. However, what you also have to do is to update a velocity. This velocity is a property of a character body 2D. You always have it. But once you overwrite it, move and slide is picking it up.
So, what is wrong with you, man? And what are you saying? Stop, please. Oh my god. Why can't I see the children? Yes, this is fine. I don't know what this bug is, to be honest, but it's stupid. Because I am the advocates. Jesus Christ. Oh my god. This is not an O2D. Or is it? Dun, dun.
Up of it is any kind of is conceived. As a consequence, let me get rid of this position. Also, I want to extend.
I see what's going on. But why? Why does it not work like this? Christ. Oh. Oh. So I had two scripts assigned before. It's fine, it's fine, it's fine. Okay. So movement, put vector, player, velocity, to velocity times this. Yeah, but this should be put on the parent object. Oh my god. This won't move. So sad. Can I change the node of this?
Then the character port want to reach be something the image. Something port I am 0 and 0 so it's look at one collision shape body has what I want to update. We have moved the player, but we have no collision. Right now, good. Now I want to shape that covers. So if we did that, quickly, you could also simply type in static body 2D and collision point. And there would be easy. And this finally to finish up the folder. This is because the bed comes, and this I want to drag. It includes delta logo GD. This script, this one for this tutorial, and click on character body 2D. Any kind of collision. So something still isn't working. And this 0 and 0. In here, we don't have the bed right now. So with the level selected, I want to click on the chain symbol to add a child scene and add the bed. And let's move it here-ish. You can still see we have the blue outline. In the game though, this is not going to be visible. This blue area is purely for debugging purposes. So you know what the actual collision shape is. That being said though, if I run the game again, I can move the player, but we have no collision. The reason for that is that the bed has a collision shape, but the player is just an image, and images cannot collide. So we have to update the player, and then we have an actual collision. Which means, once again, we have to update a node. In this case, the player is also a node 2D, but this is not what I want anymore. So I right click on it, and I want to change the type. I don't want a node 2D, instead I want to have a character body 2D. With that, once again, we get a different symbol and a warning icon. This body has no shape. To fix that, I want to add another node, which is going to be a collision shape 2D. I have this one in my recent tab. I can click on create, now we get another warning that there's no shape for this body. And for that, we have to look on the right where we can add a shape. Now for this one, the shape is getting a bit more complicated because the player itself doesn't have a regular shape. Although we can simplify things a bit. If you look at the player and squint a bit, you get more or less a round shape, which is what I want to go with. Which means for the shape, I want to have a circle shape 2D. This is now giving me a circle, and this circle I want to expand a bit to something like this. And on top of that, I want to keep position is on the UI problem. And this is we created that we I lost that thing a collision inside of the documentation.
What?
that, I am going to hold Control or Command and click on Character Body 2D. If I do that, information. We get the current velocity and that we also see is no movement at all. And once we have direction based on velocity, that is can be used for information, but for there this one has this one. Keep in mind there are two different ones. For example, you could need it by right. So with that, back inside of the player, we are updating our velocity and we are using move and slide to move this body.
Hey.
Now that we have that, let me minimize the code and return to the level scene. First of all, I want to clean things up. We don't need this logo anymore, which means I can click on delete and get rid of it. On top of that, inside of scenes, we have logo script and level C is feeling like if I double click, let me minimize it to move the character body, and it automatically includes delta. Because of that, we don't have to use delta in this process function at all. It automatically includes delta. Because of that, we don't have to use delta in this process function at all. To indicate that we're not using it, Godot wants us to use an underscore at the beginning. That way, this delta, wipe everything we're doing in there. So with that, I can run the game again, and now we have a much simpler setup. And this is
Oh, need to go. Bye bye.